252 million years ago, the planet got so hot that the ocean stopped holding oxygen. Fish suffocated in water that was technically still there. Forests rotted into carpets of fungus, and 96% of every species in the sea quietly disappeared. That was Earth at its absolute worst. But it was not the only time the planet tried to kill everything on its surface. There have been at least 5 periods in Earth's history when conditions became so extreme that survival stopped being a matter of skill. It was purely a matter of luck. Some of those periods killed the dinosaurs, some nearly erased humans from existence entirely, and one came so close to sterilizing the planet that recovery took millions of years. We are going to start with the least deadly and work our way toward the single worst moment in the entire 4.5 billion year history of life on Earth. Before the official countdown, a quick detour. About 359 million years ago, during the Carboniferous period, atmospheric oxygen levels sat at roughly 35%. Today that number hovers around 21%. That difference sounds minor. It was not. The extra oxygen did something deeply unsettling to arthropods. It allowed them to grow far beyond any size that exists today. Millipedes stretched to 8 feet long, roughly 2.4 meters. Dragonflies carried wingspans wider than a hawk's. Scorpions grew large enough to pin down a small dog. If you walked through a carboniferous swamp, you would not be a dominant predator. You would be a soft, slow, completely unarmored meal surrounded by creatures built like living tanks. Not deadly enough for the main list, but a solid preview of what this planet is capable of when the chemistry shifts. Number 5. The frozen hellscape. 20,000 years ago, during the last glacial maximum, global temperatures averaged 6 degrees Celsius colder than they are today. That does not sound catastrophic until you see what it did to the surface. Ice sheets measuring up to 2 miles thick buried most of North America and Northern Europe. Sea levels dropped so drastically that you could walk from Russia to Alaska on dry, exposed ground. The world map looked nothing like the one hanging in your classroom. Early humans survived this in small, tight-knit groups of 30 to 50 people. Their shelters were constructed from mammoth bones and tusks, covered in thick animal hides and stitched together with tiny bone needles. In Northern Europe and Asia, winter temperatures regularly plunged below -30 degrees Celsius. If you were lucky, the sun might peek over the horizon for 6 hours before disappearing again. Just keeping your body temperature high enough to avoid freezing required consuming between 3,000 and 4,000 calories every single day. Those calories did not come from a grocery store. They came from hunting 6-ton woolly mammoths armed with nothing but sharpened rocks and wooden sticks. And the mammoths were not the only threat. Cave lions, significantly larger than any modern lion, patrolled the same frozen landscape. Packs of aggressive cave hyenas competed for the same scarce prey. If neither the cold nor the predators killed you, a simple scratch could finish the job. Antibiotics were still 19,900 years away from being invented. An infection from a flint tool cut or a badly set broken bone meant your life expectancy capped out at a brutal 30 to 35 years. Number 4. The Giant's Playground. Now we jump back 150 million years to the late Jurassic period. Our ancestors at this point were not even close to human. They were tiny, rodent-like mammals hiding inside dirt burrows, doing everything possible to avoid being noticed. Global temperatures averaged a balmy 20 degrees Celsius. There was no ice anywhere on the entire planet. The continents were arranged in a formation that would render every modern map completely useless. This was the golden age of the dinosaurs, and absolutely everything operated at a scale that is genuinely difficult to process. Sauropods like Brachiosaurus and Diplodocus roamed freely, weighing anywhere between 13 and 70 tons. A single careless footstep from one of these animals would crush you like an insect. North America alone hosted over 40 known dinosaur species. The dominant predator, Allosaurus, weighed around 1.7 tons and accounted for 75% of all carnivore fossils found in certain geological formations. And it was not even the largest hunter. Saurophaganax weighed up to 5 tons. Torvosaurus reached around 4. In total, at least 10 different species of massive theropod predators shared this single ecosystem, all competing for the same food. But the real danger of the late Jurassic was not the size of the animals. It was the climate cycle. The era experienced incredibly severe dry seasons that shrank water sources rapidly. As rivers and lakes disappeared, every massive creature in the ecosystem was forced to crowd around the same shrinking puddles. Fossil evidence from these specific drought periods reveals extreme levels of cannibalism among the theropods. Desperation turned those watering holes into chaotic, bloody killing grounds where predators turned on their own kind. Number 3. The bottleneck of humanity. 74,000 years ago, the Toba supervolcano in modern-day Indonesia erupted. The sheer scale of this event is almost impossible to comprehend. It launched over 2,800 cubic kilometers of volcanic material directly into the atmosphere. To put that into perspective, that is enough ash to bury the entire landmass of the United States. The eruption triggered a volcanic winter that lasted between 6 and 10 years. Global temperatures plummeted by as much as 15 degrees Celsius. Thick ash clouds choked out the sun, which immediately began killing plant life across entire continents. Without plants, the herbivores starved. Without herbivores, the predators starved. The entire food chain collapsed from the ground up, layer by layer. At the time, early Homo sapiens were living in Africa and parts of Asia. As the climate crisis spread across the globe, the total human population dropped to a number that should be terrifying. Somewhere between 3,000 and 10,000 individuals worldwide. The entire future of humanity depended on a group small enough to fit inside a modern sports stadium. Every single person alive today descends from that incredibly tiny pool of survivors. The genetic evidence for this bottleneck is still measurable. Modern humans actually possess less genetic diversity than most primate species. The few who made it through likely survived by retreating to coastal regions in southern Africa, desperately relying on shellfish, insects, and roots as the inland ecosystems collapsed completely around them. Number 2. The Sky of Fire, 66 million years ago. An asteroid roughly 12 kilometers wide slammed into the Yucatan Peninsula, traveling at 20 kilometers per second. The kinetic energy released upon impact was billions of times more powerful than any nuclear weapon ever constructed by humanity. Anyone standing within a 1,500-kilometer radius of the impact site would have been vaporized instantly by the shockwave alone. The collision launched billions of tons of pulverized rock and dust straight into the atmosphere. Superheated debris rained back down across the planet, sparking massive wildfires on multiple continents simultaneously. Vaporized rock mixed with water vapor in the upper atmosphere, producing highly toxic acid rain that poisoned fresh water sources worldwide. Then came the darkness. The immense volume of dust and smoke blocked out the sun for months, possibly years. The sky turned pitch black. Without sunlight, plants could no longer photosynthesize, and the entire terrestrial food chain collapsed from the bottom up. In the oceans, acid rain and sudden temperature shifts wiped out phytoplankton, the tiny organisms that served as the foundational base of the entire marine food web. Roughly 75% of all species on Earth were completely eradicated. Every non-avian dinosaur, every pterosaur, and every marine reptile was gone. The only creatures that survived the end Cretaceous were small animals capable of burrowing deep underground, feeding on dead organic matter, or surviving incredibly long stretches without a single meal. That is the second worst extinction event in Earth's history, which raises an obvious question. What could possibly be worse than a planet-killing asteroid? Number 1. The Great Dying. About 252 million years ago, a massive volcanic system in modern-day Siberia, known as the Siberian Traps, began to erupt. This was not a single cone-shaped mountain blowing its top. It was an expansive volcanic province roughly the size of Western Europe, and it poured continuous rivers of lava across millions of square kilometers for approximately 1 million years. The eruptions pumped an estimated 100,000 billion metric tons of carbon dioxide into the atmosphere, alongside catastrophic amounts of sulfur dioxide and methane. Global temperatures skyrocketed by about 10 degrees Celsius. In equatorial land regions, surface temperatures breached a lethal 50 degrees Celsius, 122 degrees Fahrenheit. The only somewhat habitable zones left on the planet were pushed to the extreme poles, which transitioned from frozen tundra into temperate climates. The oceans absorbed so much heat that they could no longer hold dissolved oxygen. Vast stretches of the deep sea became stagnant, toxic dead zones. Hydrogen sulfide gas, one of the most poisonous substances on Earth, began bubbling up from the oxygen-starved water and polluting the coastal air that land animals needed to breathe. Chemical reactions in the atmosphere severely damaged the ozone layer. Extreme ultraviolet radiation battered the surface, actively mutating plant spores and killing off vegetation. Acid rain aggressively stripped the land of its remaining flora, causing massive soil erosion that washed into the seas and smothered what little marine life still clung on. Tropical forests vanished entirely, replaced by enormous fungal blooms that fed on the endless supply of dead wood. The scale of death is difficult to process. 96% of all marine species completely disappeared. 70% of terrestrial vertebrates went extinct. Even insects, the ultimate survivors that had made it through every previous mass extinction, lost more than half of their entire families. Coral reefs were wiped from existence and did not reappear in the fossil record for another 10 million years. The planetary ecosystem did not just collapse, it ceased to function entirely. It took somewhere between 5 and 10 million years for the Earth to slowly recover from the Great Dying. The planet has spent most of its history in conditions that would kill a modern human in minutes. Toxic atmospheres, boiling oceans, volcanic winters stretching across entire decades. Asteroid impacts powerful enough to darken the sky for years. Life kept returning after each catastrophe, but only barely, and only after millions of years of slow recovery. The relatively stable, oxygen-rich, temperate world we walk around in today is not the default. It is the exception. It may be the rarest version of Earth that has ever existed,